Right, let's review differentiation. So the derivative of some function f of x yields another function f prime of x, f dash of x, called the gradient function. All right, so now the gradient function f dash of x gives us the rate at which the function is changing at any given point on f of x for whatever value of x we specify. Now this rate is equal to the gradient of the tangent to f of x at that point. So here's our Cartesian plane here. Here are our coordinates x and y. Okay, here's some curve f of x here, part of it, at least from the positive part of the horizontal axis, positive part of the x-axis. And here's some point x equals a. At that point, there's a tangent, a straight line that touches the curve at the one point only. It's tangent to the curve. Okay, that tangent makes an angle of theta with the positive direction of the x-axis. That'll be relevant later on. Here, so x equals a has y coordinate f of y. All right, so f of x is a given function. F prime of x is a gradient function. F prime of a at x equals a is the value of the gradient function at x equals a. F prime of a is the rate at which the function f of x is changing at x equals a. And f prime of a is equal to the gradient of this straight line. So all along the straight line here, the gradient is obviously one fixed value, and f prime of a is the gradient, the slope of that line. Okay, it's also equal to f prime of a is equal to the tan of the angle, and that's the angle between the tangent and the positive direction of the x-axis there. So tan theta gives us the gradient of this line, which is also the gradient of the function itself at the point x equals a. All right, now let's have a look. Product rule. Product rule: if y, some function y is a product of two parts u and v, two terms u and v multiplied together, then dy dx by the product rule is u times dv dx plus v times du dx. Okay, because y is a function of x. I should have put in there y equals y of x. All right, now as an example, let's say y equals x squared times sine x. Let the x squared be the u part, sine x be the v part, then dy dx. The derivative of the function is u times dv, so x squared times the derivative of sine x, which is cos x, plus v, sine x, times the derivative of x squared, which is 2x, and that's our end result. We could, of course, tidy that up, but you see what's going on. Let's have a look at another one, quotient rule. Okay, let's have a look at the quotient rule. If y is the result of the division of two terms, u and v, then dy dx is equal to v du dx minus u dv dx over v squared. Okay, after use it long enough, you'll get used to using it, but there are other ways of doing it. Okay, so let's say we start with y equals x squared on sine x. So x squared will be u again, sine x will be v, then dy dx will be v sine x times du dx is 2x, minus u x squared times the derivative of sine x is cos x, okay, over v squared, which is sine squared x, and then tidy it up a bit. Okay, chain rule. Chain rule, if y equals some expression u, which is a function of x, then dy dx is dy du times du dx. And examples are probably the best way to show this. So let's say we start with y equals 5 times, in parentheses, 2x cubed, right, plus 7x, all to the power of 4. Okay, well, what you can do is that you could call that bit inside the parentheses, you could call that bit u, okay, and this would then become 5u to the power of 4, and then we just do differentiation of that, and this is where the chain rule comes in. So dy dx becomes 4 power of 4 taken out front here, 4 times the whole thing, 5 parentheses 2x cubed plus 7x to the power of 3 now, so reduced by 1, times the derivative of everything inside the parentheses because we called that u, because remember we need dy du, that's this bit here. Then we need to go inside the parentheses, du dx. So we need to go inside u and differentiate u, so du dx. Well, the derivative of 2x cubed becomes 3 times 2, 6x squared, plus, and then the derivative of 7x is just 7, so we get plus 7. Okay. I've really shortened that down, but you should all be familiar with that, hopefully. I don't think there should be any issues with that, but just as an example of a chain rule. Tan rule. If y equals tan k times x, where k is some sort of constant, can I just say k here belongs to the reals, then dy dx is k times sec squared kx. Remember, sec squared is secant. Sec is secant, sorry, which is 1 on cos. Okay, so k secant squared of kx. All right, and that's that.